Welcome everyone to Physica. So in this video we will solve some of the quantum mechanics questions of CSR Net June 2018, and I have already solved some of its question, so you can watch in the playlist and you can also watch previous year questions. So please do subscribe, like and share this channel with others, and it also motivates me to make such videos in future. So please do that, and it takes a lot of time, efforts to make such videos. Okay, so let's start the video, and I have included the PDF of this question paper and other papers also in the description. You can see from there the question paper. This is for booklet A. Okay, now the 56th question is, these are quantum mechanics question and these are of 5 marks questions. So I will do 2 questions of quantum mechanics. Those are 5 marks. The energy of a free relativistic particle is, the energy is given to be under root p square c square plus m square c4, where m is the rest mass, p is its momentum, and c is the speed of light in vacuum. The ratio Vg by Vp. So you have to calculate Vg by Vp. That is the group velocity by the phase velocity of the group velocity Vg of a quantum mechanical wave packet describing this particle to the phase velocity Vp is. So you have to calculate Vg by Vp. Now there are many methods to calculate the same problem by different methods, and this is the easiest question you can get in 5 marks on quantum mechanics. Okay, so let's solve. So we are given that the energy is given by, I will write the energy here once again, p square c square plus m square c4. Okay, m is the rest mass of the particle and p is the momentum, c is the speed of light. Now the group velocity, you know the formula for the group velocity, Vg is d omega by dk. Okay, now this energy you can write it this way also, squaring both sides. You can E square is equal to p square c square plus m square c4. Now this is a function of E and P. This is a function of E and P. All other quantities remains constant only. C square, C and M remains constant. So this is a function of E and P. Now you have to change this differential term into E or P. You have to change that in order to get d omega by dk. So how you can do that? You can relate them, because you know the energy of a photon that is given by h nu, or you can divide and multiply it by by 2 pi. Divide and multiply by 2 pi nu, that will give h cross omega. Okay, and you can also do that for momentum. You know momentum p is equal to h by lambda, and you can multiply and divide by 2 pi and you will get h cross k. Okay, so from here you can replace omega here. So in place of omega you can write E by h cross, because E is equal to h cross omega. So omega you can write as E by h cross divided by, you can write in place of k, p by h cross. So p by h cross, that will give, h cross term would come out and it will cancel from both the sides. From numerator and denominator, h cross will cancel and you will get dE by dP. So Vg can also be written as dE by dP. Okay, it is d omega by dk, but you can write it as dE by dP. So you can calculate dE by dP from here, because it's a function of E and P. So differentiating this whole equation with P, because you want to get dE by dP term. So differentiating this whole equation, you will get 2E dE by dP, and that will be equal to 2P. This will give 2P c square plus, this is a constant term, so this will give 0. Now 2 and 2 will cancel, and you want to calculate dE by dP. So dE by dP would be equal to pc square by E. So this is dE by dP, and you will get dE by dP you got. So the group velocity is same. This will be p square, this is p square c square by E. Okay, now we can calculate the phase velocity. You calculated the group velocity, now you have to calculate the phase velocity. Phase velocity is simply omega by k. Okay, and omega you can write it as E by h cross, and k you can write it as p by h cross. Okay, here also the same thing we did, but it's in the differential form. So h cross, which is a constant, came out. Again h cross here will cancel, and Vp will be equal to E by P. So you should know these formulas in advance only. Okay? So you won't calculate these formulas in the exam. I am just explaining you how you can do that if you don't know. Okay? So you have to know these formulas in advance in exams. So Vg is d omega by tk, and it is also equal to d by dp, and Vp is equal to omega by k, and it is equal to E by P. So now it's simple. You have to calculate the ratio Vg by Vp. Vg you calculated as d by dp, that was equal to p square c square, sorry, p c square. I wrote it here wrong. So it is p c square by E divided by E by P. Vp is E by P. So this will give p square c square. P would come up, and this will become p square c square by E square. So this will become p square c square by E square. So Vg by Vp is p square c square by E square. So C option is correct. Here C cube is given, but in the original question paper, this is a misprinting here. In the original question paper of the CSR Net June 2018, it is C square only. Okay, so consider it as a C square. Okay, consider this as p square c square by C square. So C option was correct, and this was of 5 marks. So this much easy question. If you know Vg is equal to d by dp, and if you know Vp is equal to E by P, you can simply calculate, and it's just a 2-minute question. I think you can calculate it by various methods, like you got Vg here, which was d by dp. You got this way, and you got it as p c square by E. Okay, and you know that E by P is Vp. In spite of E by P, you will write Vp. So we will get another relation, which is Vg Vp is equal to C square. Okay, this relation is also important. They can ask about this relation also. So now what you can do is you can multiply and divide by Vp, because you want to calculate Vg by Vp. So you can multiply and divide both sides by Vp, or divide both sides by Vp simply. Okay, so Vg by Vp, you want only this term. So you can throw Vp down there, and you will get Vg by Vp is equal to C square by Vp square, and that will be equal to C square by, you know, Vp square. What is Vp? Is E by P. So E square by P square. So P square will come up, so it becomes P square C square by E square, the same here. So it's a different approach. Just I think the approach is same, but you calculate in a different way. So next question is from the WKB approximation. So this question is again of 5 marks, and it was again a very simple question. The 57th question is the nth energy eigenvalue En of a one-dimensional Hamiltonian is. So energy eigenvalue is given of the Hamiltonian p square by 2m plus lambda x raised to power 4. This is the Hamiltonian given, where lambda is greater than 0 is a constant. Lambda is a constant in the WKB approximation. So this is k, this is misprinting. In the WKB approximation is proportional to. So you have to calculate from the WKB approximation, or we call it semi-classical approximation. So either term can be used. So Hamiltonian, you know, you can write it as kinetic energy plus potential energy, sum of kinetic energy, which is p square by 2m, plus potential energy. So this is the potential energy term. I want to tell you the potential term Vx here is lambda x raised to power 4, and I'm using a shortcut method of WKB approximation. You can calculate by the long method, in which first you have to calculate the turning points, then you will apply the quantization rule using the WKB approximation. So then you will get your answer, but it's a very long method. So we will put a shortcut here. We will use a trick, so by which you can use in exam also, because this trick is very helpful in doing WKB approximation. I have solved many questions earlier also using this trick, and it works very fast. So you can get your result in a in just a minute. So you can use this trick in exam. Okay, so you have to know the both the methods. By the way, you have to know the long method also, because sometimes in some questions the trick can't be used, so you have to know the other method. But in this question I will use the trick. If the potential of this form, Vx is equal to alpha x raised to power m. So if the potential is given of this form, alpha some constant times x raised to power m, x has the power m, then the energy eigenvalue by WKB approximation is given by alpha n plus half, n is the quantum number, n plus half h cross under root pi by 2m alpha gamma 1 by m plus 3 by 2 divided by gamma 1 by m plus 1, this whole bracket raised to power 2m by m plus 2. Okay. Now what you can do here, the potential, you just look at the potential. So what I did, I already wrote the potential is in this form. So here the potential is Vx is equal to lambda x raised to power 4. So what you do is simply you substitute all the values and you will get, because you have to calculate the powers of lambda and n plus 1. So here alpha is lambda and the power of xm, that is 4. So you can calculate, because you have to calculate the energy eigenvalue En of a one dimensional, the nth energy eigenvalue. So En will be proportional to, now alpha is lambda, so lambda comes here and lambda comes here. Okay, because alpha is here and alpha is here. So don't confuse proportionality sign with alpha, because they look the same. So alpha is here and alpha is here. So in place of alpha we have to write lambda, because in the question it is lambda. So lambda, and here comes lambda. So 1 by under root lambda comes here, and this whole raised to power 2m by m plus 2. So m here is 4. So you will 2 into m by 4 plus 2. So this will be proportional to lambda, and this is 1 by lambda raised to power half you can write, and this will be 8 by 6, that is 4 by 3, and that will be proportional to, and you can also write the power of n plus half also here, that is n plus half raised to power, because n plus half is here, and this will whole raised to power 2m by m plus 2, the same here. So it is again 2 into 4, 2m by m plus 2, that is 4 plus 2. So En will be proportional to lambda, this will be lambda raised to power, this will go up and this will become minus half, and this is 4 by 3. So 2 will cancel, and this will give minus 2 by 3. Okay, and multiplied by n plus half raised to power 4 by 3. So En will be proportional to lambda raised to power, this is lambda raised to power 1, this is minus 2 by 3. So 1 minus 2 by 3, and n plus half raised to power 4 by 3. So En will be proportional to, so I wrote here En is proportional to lambda raised to power 1 minus 2 by 3 is 1 by 3. So lambda raised to power 1 by 3 and n plus half raised to power 4 by 3. So this would be the answer. So out of these options you will see the first option is this only, n plus half raised to power 4 by 3 and lambda raised to power 1 by 3. Okay, so the same answer. So you can remember this formula only, okay? And I will show you some more shortcut. So you can also write in this way. You can extract the value of alpha from here and n plus half here, and you will get another shortcut, that is En will be proportional to n plus half raised to power 2m by, okay? If they ask only the proportionality on the quantum number n plus half or n and the alpha, okay? If they ask only on alpha and n plus half, then you can use this formula only. En is proportional to n plus half raised to power 2m plus 2m by m plus 2 and alpha raised to power 2 by m plus 2. So if you solve this, alpha into 1 by root alpha raised to power 2m by m plus 2, you will get 2 by m plus 2. So you apply here in this question, you will get En will be proportional to n plus half raised to power 2m by m plus 2. So m is 4 here. So 4, 8 by 6. So that will be 4 by 3. And alpha raised to power, alpha is here lambda raised to power 2 by m is 4. So 2 by 6, that is 1 by 3. So you will get the same answer in a very short way. So you have to remember these formulas. So if the question, I think in one of the previous year questions, the question came that you have to tell only the proportionality on the quantum number n. So you simply know that the En proportional is proportional to n plus half raised to power 2m by m plus 2. So you can only calculate this, and this was a 5 marks question. So how easy is this question by using this trick? So these were the 2 questions I solved. So please do subscribe this channel, and thank you.